Welcome to SLUG 2021, another year of virtual presentations. We are very excited to bring this event to you via the live stream and hope that you will enjoy this and the other presentations. I am Jason Booth and I oversee the support staff here at SchedMD. Just a quick overview of the agenda. You are currently watching the first session. In this session, I will be covering field notes from the Frontlines of Slurm support. We will be doing 5 separate presentations with 5 different streams. This and the following presentations will remain available on SchedMD's YouTube channel for at least 2 weeks after SLUG 2021. You can view the stream on our YouTube channel or directly through the links from the agenda. Feel free to ask questions through the YouTube chat. Chat is moderated by the SchedMD staff. You can identify them in chat as they have the wrench icon next to their names. Questions through the chat will be relayed to the presenter by one of the moderators, and we may defer some of these questions to the end if they cannot be relayed in a timely fashion. Note that some questions may be answered by the moderators directly. It has been our tradition over the last several SLUG conferences to cover what we have nicknamed field notes, which are common issues we see from sites we work with. This presentation builds off of last year's slide deck and live broadcasts, which are accessible through the SchedMD Publications website and our YouTube page. This should be a meaningful topic for your site, and I hope your site finds value in what I have prepared. Because these field notes build off of last year's slides, you will see some familiar topics refreshed and new ones. I like to refer to these items as golden nuggets of knowledge that our support team sees often. So let's talk about the purpose of the many topics I'll cover today. The purpose is to show you how to get the most out of your support experience and to point you in a better direction while setting up and working with Slurm. All right, going over the agenda for this presentation. As you will notice, these topics are somewhat grouped together. However, I do split off into more non-related topics, especially near the end of this presentation. So I have labeled these as random notes and observations. I'll get into a short history of SchedMD and Slurm to better understand the company and the developers behind Slurm, the best practices when upgrading to newer versions of Slurm, adding and removing of nodes, a feature we see more and more adoption of called Configless, a new feature for storing job scripts, and Slurmdbd purge, log, rotate, and archiving. A few notes on scalability and what you should be aware of, a quick note on Cgroups, and a few random notes on coredumps, debugging, and finally our support offering. All right, so the history. Slurm has been around since 2002 and has come a long way since its early days as a resource manager. In the past, Slurm used to be an acronym, which stood for Simple Linux Utility for Resource Management. It surprises us to see the use of Slurm in all capital letters even after so many years. We don't refer to Slurm in all capitals anymore, and we had not done so for many years. The official change happened in 2012. Today, when using Slurm, you should only capitalize the first S and the rest in lower cases. As mentioned previously, Slurm has been around since 2002. SchedMD, as a company, was not far behind, following just 8 years later. SchedMD opened its doors in 2010, offering part-time customer Slurm development 100% owned by Danny Abel and Morris Jetty. In 2011, Mo and Danny made SchedMD their full-time passion. In 2014, the team started to grow, and so did interest in Slurm. In 2016, SchedMD relocated from Livermore, California to Lehi, Utah. Since then, we have moved to a new, larger location in Lehi to accommodate our growing business needs. In 2017, we had 11 employees, mainly support and development engineers. And as of 2021, we are a healthy 28 employees with the bulk of our staff in support and development. SchedMD's company goals are to provide amazing commercial support for Slurm, make sure we keep our dominance on the top 100 systems, and to keep Slurm open source. Slurm adoption has been fun to watch and humbling to see as a company. And although we do not know how many sites run Slurm. We do know how many sites SchedMD supports. As you can see, the adoption and interest in Slurm has just ballooned in the last 6 to 7 years. From 67 sites in 2013 to our now 460 sites in 2021. As a company, we thank you for your support. This allows us to do what we love and provide you with an ever-improving, excellent scheduler. One final note here. We are hiring, and we are looking for C developers who are interested in working with Slurm and who also enjoy supporting Slurm, our Slurm user base. If you are interested, we invite you to apply to work with us. You can do so via our careers page or by emailing us at the email address above. Now, let's get into the field notes, starting off with the system requirements. This is a noteworthy topic as we often see several questions like this. What type of hardware do I need to run Slurm in my environment? Starting off, the controller prefers faster, fewer cores. So a system with, say, 4 cores and a high clock speed will perform better than a system with 6 cores and low clock speed. The controller also performs better with fast access to state save location. The state save location is a configurable option found in the slurm.conf and should be on some type of fast storage such as NVMe. The reason for this is listed in the details above. Slurm does a lot of file access, and that access grows with larger sites and large workloads. Note that for those sites and users who like to spawn lots of jobs, you can make use of job arrays to help reduce the strain on storage, as this will only store one job script and environment file per entire job array. Continuing on, as mentioned previously, Slurm prefers high core frequency over core count. The memory depends on the number of jobs your site pushes through in a given day or week, and also depends on if you plan to run the Slurmdbd on the same system. We generally recommend a system with at least 16 gigabytes of RAM, a dual-core CPU with high clock frequency, and dedicated SSD and NVMe. This assumes that you are doing about 100,000 jobs a day and about 700,000 jobs a week. Note that the amount of RAM required will increase with larger workloads and node counts. Using the same example as before, 700,000 jobs a week, we recommend the following for the Slurmdbd: a system with a fast disk NVMe or SSD and lots of RAM, 16 to 32 gigabytes. The RAM requirement goes up in relation to the number of jobs you wish to store or query. The CPU selection here is not as important as the Slurm controller, so you have more options for the Slurmdbd. So I would say this system would be just fine for a site that has 500 nodes and pushes 100,000 jobs a day or 700,000 jobs a week. Moving along to upgrading. There are a number of reasons to upgrade. Probably the most compelling is that we target the most recent release for bug fixes, which as of today is 2108. Along these same lines, we continually optimize, rewrite code, and make scheduler improvements. So if you are on an older version such as 1808, consider upgrading soon. For our supported clients, their support contracts require staying on a current release. Plus, by upgrading, you get to take advantage of all the performance and enhancements by staying current. When upgrading, you should follow the upgrade procedure found on our website, which I will go over. There's a specific sequence to use when upgrading between major versions of Slurm. We have built-in support for the last major 3 releases, so long as you follow the hierarchical sequence. The Slurmdbd needs to be greater than or equal to the Slurm controller. The Slurm controller needs to be greater than or equal to the Slurmds. You can include in here that the Slurmds need to be greater than or equal to the Slurmstepds if you are upgrading with running jobs. Although generally speaking, sites drain the cluster when moving between major releases. So, should you choose to upgrade with the running jobs, then you'll want to open up a support request with us so that we can assist you with your upgrade needs. Continuing on, the Slurmd needs to be greater than or equal to the client commands. Also note that you can mix maintenance releases without issues, but it will make our support staff question you about your setup when they see this in your environment. So for example, you could mix 20.05.05 and 20.05.2. Just a side note about RPMs. Although we ship and support the Slurm.spec, our general recommendation is to not use RPMs to install Slurm. Instead, we recommend that you use version-specific directories and use symlinks or module files to manage versions. This makes rolling upgrades much simpler, as you just have to replace a symlink. Here's an example of an upgrade procedure we recommend. You can see we have an apps directory that we use as a prefix for Slurm, and under that Slurm directory, we have stored the 21.08.0 release. To make upgrades easier, you can then use a symlink to the services you share out to the cluster. In this case, the DBD refers to the Slurmdbd, the CTL, the controller, the D, the Slurmd, and current represents the current version of Slurm. Each of them can then be shared out over a shared file system such as NFS. Make sure to reference these symlinks in each service file, as well as any environment path to the profile.d or module file. This procedure makes rolling upgrades much simpler just by moving a symlink when you are ready for an upgrade to the next release. Backing up the MySQL database used by Slurmdbd is strongly encouraged when upgrading. You should probably be doing this already as part of the regular backup strategy, but this would be a good time to make sure those backup methods work. For example, verify that the MySQL dump command is actually exporting data from MySQL and that the data exported is complete. For larger databases or more unusual systems, you can test the upgrade database conversion with a copy of your full production database on a separate machine. This separate system could be a spare blade or a VM you have with a later version of Slurm installed. You'd restore the database and set the correct slurmdbd.conf parameters to point to that database, and make sure the test system slurm.conf has the same cluster name as production. We highly recommend using more recent versions of MySQL or MariaDB, not only for their security patches, but also performance and bug fixes. We have seen a handful of bugs reported where the fix for database conversion issues was to upgrade from MySQL or MariaDB 5.5. Slurmdbd will automatically convert the MySQL schema for you. This can take 10 to 15 minutes or more depending on the size of your database, and can increase with underlying slow system storage. We highly recommend taking a backup of the state save location as well. The state save location and database dump can help assist recover from a failed upgrade attempt. Please note that once a daemon has been upgraded, you cannot roll back to a prior version without losing data and your job queue. All right, moving along, node addition and removal. Adding and removing nodes in Slurm is a sensitive operation. This seems to cause problems for each site, at least once early on. Certain internal data structures are built off the node list at startup and are used within communication subsystems. Changing the node definitions and restarting only the controller will usually lead to communication errors as messages are misrouted internally. For adding or removing nodes, we recommend that you stop the controller, change your configs, restart all the Slurmd processes, and then start the Slurm controller. Following this procedure will ensure that the entire cluster has the correct layout for proper communication. A less safe method, but usually okay, would be to change your configs, restart the controller, and restart all the Slurmd processes really quickly. As a side note, there are longer-term plans to make this process less painful. However, there is still some work needed, which also relies on us moving away from cons res before that work can take place. Some of the needed changes already exist in cons res today, with separation of some of these data structures. A word of warning, We have seen a number of clusters use no-conf hash and config overrides as a way to improperly add or remove nodes or even change the configured resources on a node. Please do not do this. Those options are there to tell you when something is wrong. Your config file should be synced across the entire cluster, and the running config, this is the in-memory config, should match on all of the Slurm controllers and the Slurmds. There are some use cases for these options. However, a production environment should ask themselves what they are doing and what they are trying to accomplish when considering these parameters. Now on to an exciting topic of Configless. I'll get into the details here in a moment, but I wanted to take some time and say that I really believe this is the future of managing Slurm configuration files. I know each site has their own method of deploying configuration changes. I hope that you might consider this feature for your cluster. Configless Slurm is a feature that allows compute nodes, specifically Slurmd processes, and the user commands running on login nodes to pull configuration information directly from the controller instead of a pre-distributed location. This means that there is no need for a shared file system mounted on each compute node housing the configuration files. Your cluster does require a central set of configuration files on the Slurm controllers. Configless in one sentence means that the compute nodes, login nodes, and other cluster hosts do not need to be deployed with local copies of those files. There are no extra steps required to install this feature. It is built in by default, starting with Slurm 2002. Even though there are no additional install steps, there is still a Slurm CTLD parameters called enable configless that you add to your slurm.conf on the controller. Adding this option does require a restart of the Slurm controller. The setup on the compute nodes is just as simple as the server, and there are two options available to you to enable this. You can start the Slurmd with --comp-server and specify the server name, or a DNS-SRV record is also supported. When using DNS-SRV record, the compute nodes should not have local configuration files on them, as this will cause the nodes to honor what is in the local configuration file over server issued config files. We will get into the hierarchical order for this in a bit into the next few slides. The --comp-server will provide the required information to the Slurmd on startup, enabling the service to pull down the needed configuration files. In this example above, for --comp-server, the server Slurm CTLD primary runs on port 6817. For the DNS-SRV record, as shown above, multiple SRV records can be specified if you have deployed Slurm in an HA setup. The DNS-SRV entry with the lowest priority should be your primary Slurm controller, with higher priority values for backup Slurm CTLDs. So I have one quick question here that came through. So for configless mode, how often will the Slurmd contact Slurm CTLD for config stuff? Hopefully this is at startup. For Slurmds, yes, on startup. It reaches out to the Slurm controller, pulls down configs, and it stores that in a cache directory, which I'll go over here in a second. You can actually verify your setup by looking in that cache directory. For client commands, which we'll get into in a second, there are some ways you can avoid the client commands from contacting the controller every time it has to run a job or pull down that configuration. All right, so as you can see here, I have a visual representation of a basic cluster with a Slurm controller setup with the enable configless option, a Slurmd, two client-side systems where client commands can be ran. The light blue represents the server where all the Slurm config files are stored, and the orangish yellow represents configless clients. This includes Slurmd. Some caution should be taken for clients. There are basically two ways that work. On nodes with Slurmd's running, it is assumed that you won't have a default slurm.conf file, so it just checks in the synced location for one. By default, this is the conf cache directory found in your slurm spool directory. If you don't run a slurmd on a node where client commands are issued and it can't find a config file, the last thing it tries is to use the DNS SRV record to look up where the slurm controller is and request configs. A word of warning when using just DNS entries. If you have a large grouping of jobs being submitted, you may experience an RPC flood. I'll talk about that a little more in a later slide. We generally suggest that you run a slurmd to manage the configs on login and submit hosts that run client commands, and just not let jobs get scheduled on your front-end client nodes. In this way, the client commands will pull from the local cache storing the config files. So what you are trying to avoid is a bunch of client commands that also need the server to send the config files back to them. This obviously does not scale well with many jobs being submitted at once. This is a continuation of the small Configless setup earlier. We have added the slurmd processes to the two client nodes. These slurmds can point to the slurm controller, but not reside in any partition. This will then allow the client commands to access the config files from the shared conf cache directory that is created by the slurmd process and avoids having the client commands requesting configurations from the server. With this setup, the cluster will perform much better and there will be fewer RPCs. With the controller configured and the slurmd started, you can verify the setup by checking in a couple of places to make sure that the configs are present on the node. Config files will be in slurmd folder under conf cache. And a symlink to this location will be created automatically in /run/slurm/conf. You can confirm that reloading is working by adding a comment to your slurm.conf on the slurm controller node and running scontrol reconfigure and checking the config was updated. Note that there is a hierarchical order to how slurmd and clients behave in a configless setup. First, the --conf-server is checked. Second, the -f is then checked to see if a valid configuration was specified. Third, the slurm_conf environment variable is checked. Fourth, the default config path is checked, most commonly /etc/slurm.conf. Lastly, DNS SRV record is checked. As noted previously, if you are using DNS SRV records, make sure local copies of the configs are not present on these nodes or submit hosts as they are honored over any DNS SRV records. So here's a slide that covers which conf files are copied over. Note that we do not copy any include files with this solution, so please take measures to either consolidate your include configuration files into one or use some other method to distribute them. There are a few known issues at this time. The Perl API does not work with Configless prior to 20.02.6. This affects sites using the integration scripts. Hopefully you stay current and you don't run into this issue, but if you are on a later version, please upgrade. As mentioned already, any include files will not be distributed with this model. Adding and removing nodes is still not supported even with Configless. As a final note here, and because it does not fit anywhere else in my presentation, if you still plan to use a traditional method and distribute conf files, please do not ignore the conf mismatch errors. When you see these errors, they should be a priority to resolve. Archiving job scripts. Slurm now supports the ability to archive job scripts into the Slurm database. If your site is on 20.11.5 or later, you can take advantage of this today. This was sponsored by Yale, and more detail can be found in our documentation. There are a few changes you need in your configuration to support this, which I will go over. To enable this feature in your environment, you need to have the Slurmdbd enabled and configured correctly in the Slurm controller. Then in your slurm.conf, you will need to add the new accounting store flag job script. This will instruct Slurm to archive job scripts into the database for later retrieval. A noteworthy mention here is that with the addition, we also renamed the previous accounting storage job comment to job comment, and now require it to be set on an accounting storage flags. Finally, it is also worth pointing out that admin comments and system comments are always recorded to the database. Slurm also has the ability to limit the job script size stored. Part of this new feature comes with the ability to set a scheduler parameters of max job script. By default, this is 4 megabytes. Larger values may have a negative impact on your system, so please use caution here. To query the job script, you'll need to specify the option --batch-script with sact. Other semi-related options here are the fields, submit lines, and comment lines, which you can access with the sact-o option. You can view more options with sact-help format for these and other options available to you. So before moving on to the next subject, I have an example for what that shows when you run sact with batch script. You can see a simple script that sleeps and prints the environment. Simple, but demonstrates this feature. All right, Slurmdbd purge and dbd archiving. We see questions on this often, and so I have a few comments to share with you regarding database archiving and purging. The Slurm database can grow quite large over time. As an admin, you have some options available to you to help prevent the database from growing too large, namely backing up your database, truncating old usage, job and event data. Slurmdbd also provides a set of options to automatically purge and archive data. For sites that still wish to access old data, this information can be stored in a non-production instance of Slurmdbd. The purge options can be used to specify when the purge for a respective entity occurs. The default value for each of these options is to never purge. However, a value of say 12 hours would purge everything older than 12 hours. A purge of 12 months, purge everything older than 12 months. Just a side note about archiving Slurmdbd instances. This Slurmdbd instance is separate from the archive option just covered. This is an isolated instance of the Slurmdbd that runs a copy or part of a copy of the database. It is possible to restore an entire copy or part of the production database to some other instance of Slurmdbd. In this way, historical information can still be queried without loading in old archive data files on the production system. If you have questions about this, we encourage you to log a support case with us for details. The benefits of purging or archiving are that these do not impede production and help admins only worry about keeping that information that is only necessary for their production environment. One drawback is that this information will be on a separate instance and most likely a different machine. All right, moving on to scalability. To start off the conversation on scalability, I wanted to talk about the state save location. Slurm's performance and responsiveness under heavy load will be governed by the latency of any reading and writing operation from the state save location. Your system's throughput and overall responsiveness under heavy load will be governed by any latency on the state save location. Special consideration should be taken here, especially high throughput environments where there is a workload of a large number of short-running jobs. You may be better off with having an NVMe drive in a single controller in this instance. Some sites use an NFS mount that is also shared with users, and these shares can be frequently taxed. In these setups, you are most likely to see performance issues. As of Slurm 2011, there is a new undocumented Slurm CTLD parameters option called Enable RPC-Q. This option may alleviate high contention between RPC processing threads in some environments. Enable RPC-Q creates a queue of RPCs instead of handling RPCs one by one in a separate thread, which can create RPC storms. We handle RPCs in batches, still using thread, but doing it smarter. For those sites who have support, it would be a good idea to let us know if you intend to enable this experimental feature, especially in production. Another word of advice when dealing with lots of jobs, nodes, and client requests: increasing the default number of munge threads can help alleviate contention and avoid resending messages that may have timed out while munge was busy servicing a few requests. For this, we suggest setting munge thread to 10. Any cluster may benefit from making this change without the worry of it causing negative impacts on the system. Another pain point that we see every so often relates to how often the identity management system is accessed. Hundreds of thousands of queries can cause latency issues and cause jobs to time out with sites that are very active and have a high throughput workload. For this unique case, Slurm provides NSS Slurm. This option, NSS plugin, permits PSSWD and group resolution for a job on the compute node to be serviced to the local Slurmdbd process. The advantage here is that a site can reduce the number of queries against LDAP, SSSD, and NSLCD. And for sites that burst out into the cloud, there's no need to duplicate identity management services on those cloud compute nodes. NSS Slurm is not meant as a full replacement for network directory services such as LDAP, but is a way to remove load from those systems to improve the performance of large-scale job launches. It accomplishes this by removing the thundering herd issue should all tasks of a large job make simultaneous lookup requests, generally for info related to users themselves, which is the only information NSS Slurm will be able to provide. Please note that NSS Slurm will only return results for processes within the job step. It will not return any requests for processes outside these steps, such as the system monitoring, node health check, prolog, epilogue, and related node system processes. Of course, there are other measures you can take to improve your system's responsiveness today, such as tuning the scheduler parameters, adjusting times, the previously mentioned use of job arrays, adjusting your U limits, disabling unnecessary plugins, limiting logging to error messages only, turning on caching in NSCD and SSD. Of course, you are welcome to reach out to support with your questions. There's also a good set of information found on our high throughput page. Moving on to Cgroups. We'll cover some brief information here. This section mostly relates to recent changes. As of 2108, Cgroups v1 has been rewritten. With this rewrite, we have fixed a number of issues and bugs and added better error logging. The benefit with these changes are a seamless transition when upgrading. There are no special considerations or config options here. The end user should not notice this change at all. Many sites that use Cgroups have also ran into a number of errors, such as unable to open some path, unable to get Cgroup, device or resource busy, no such file directory, or a Cgroup that already exists. 2108 fixes these and other issues. Even if your site has not seen these issues, but you use Cgroups, you should be making plans to move to 2108, as you eventually will run into one of these issues. Moving along, a quick note on TaskPlugin. We recommend stacking Task Affinity and Task Cgroup together. We have seen a number of configurations where only Task Affinity is set up, which is not ideal. Most sites want to set the Task Affinity and Task Cgroup, as this combines the best of both worlds when constraining resources. Note that both options will enable the srun-cpu bind and --mem bind options. Finally, a note on task affinity found in the cgroup.conf. We are considering removing this option at some point, so sites should look at using TaskPlugin as part of their future upgrade plans. And if you have questions, please engage us on the support side and we'll help you out on your transition. And as mentioned before, if you're seeing Cgroups issues, please make plans to test 21.8 and then upgrade. Before I end with a word about our support organization, I wanted to mention a few random notes. Here are a few random suggestions related to coredumps. We hope you never get one, but should you, we recommend knowing the location of your coredumps. If the Slurm controller is started with a -D option, then the core file will be written to the current working directory. If slurmctld log file is an absolute path, the core file will be written to this directory. Otherwise, the core file will be written to the state save location or /var/temp as a last resort. Please make sure that the coredump location is accessible by the Slurm user and that the user has write permissions on that directory. If none of the above directories has write permissions for Slurm user, no core file will be produced. For testing purposes, the command scontrol abort can be used to abort the controller and generate a core file. Please do not send us your core files. In almost all cases, we will not be able to read them. Please do gather a backtrace for us to review with the following GDB options mentioned in this slide. There are other considerations. Please see the frequently asked questions page for further details. The final random suggestion to be aware of are debugging options. Each service has a -D flag, which will run the service in the foreground and print debugging directly to the terminal. Note that you would not normally use these unless directed to do so by support. However, these are useful if, say, a service such as Slurmd is not starting, and the logs do not contain enough information. Continuing on, there are also some useful commands to be aware of. If you want to change debugging for the controller, but do not want to edit your config file, you can issue an scontrol set debug followed by the debug level. Note that this will only affect the scheduler and not the Slurmds. For Slurmds, you will need to modify the slurm.conf and issue an scontrol reconfigure. For client commands, you can use the -v option, which will generate logging for that command directly to the terminal. Multiple -vvv options can be used to increase the verbosity of that output. As a neat trick, I have included the sbatch --test only option, which will validate the job script and return an estimate of when the job would be scheduled given the current job queue. This is a dry run and no job actually gets submitted. This can be handy for those users who log help desk bugs and want to know if they are submitting correctly or want to have an estimate of when they can expect their jobs to start. Before I briefly cover our support, I wanted to also say that the tips and tricks I have covered today are some of the most common ones we use in support. There are, of course, many other tools that we did not cover today. And if you are interested in what is available to help you as a site, then please do engage us via our support group. So SchedMD offers level 3 support only. This is development support and puts you right into contact with the development team. We do ask that customers be comfortable with the day-to-day operations and know how to troubleshoot and be able to do the initial setup. We also offer on-site training to assist with initial onboarding and software configuration. If you have any questions, feel free to reach out to us via email with those questions. And the email can be found in this slide. Our workflow as a company and as a support starts with our bug tracking system. For this, we use Bugzilla. This allows transparent handoff between engineers and thorough tracking. By default, these bugs are public, however, we can make these private when requested. We offer specific contractual timelines for each service severity level. Our support staff also covers from 2 a.m. Mountain Standard Time to 5 p.m. Mountain Standard Time, Monday through Friday, with engineers across Europe and North America. We pride ourselves on beating the service level agreements, the SLAs, regardless of your system size and complexity. All right, I'm going to go over to the questions. I have one here from Sean. The number of munge threads or just the Slurm controller or all nodes in the cluster? So you want to modify this on the controller. That's going to be the busiest. The only way you might want to do this on the compute nodes is if you have a lot of fast running jobs, but I wouldn't think that would be necessary on the compute nodes. Controller for sure. Demorum, what is the benefit of Configless other than you no longer have to have an NFS shared comp directory? Yeah, so it's a method of deploying. So some sites do prefer to deploy via NFS. This just makes it easier. So if you want to just have inside of your service script that comp server, it will pull directly from the Slurm controller, so there's no need to push that out to an NFS, share that across. It just pulls it directly from the controller. Christopher Coffee, any cons enabling that? Enable RPCQ. So we would definitely recommend that you engage us in support first and have plans to roll it back if you see negative impacts. But it still being a feature preview, just be careful with that and let us know so that we can help you out if you run into any bugs. And then just one clarification on the storage of batch scripts. That is a 2108 feature, and I misspoke there. It exists in 2108, not 2011. Heater. Do we also have to restart all daemons when adding and removing nodes in Configless mode? So yes, the same procedure for adding and removing nodes in Configless still applies. Joe, any concerns using Samba CIFS instead of NFS for shared storage for nodes? I guess why? There are many other options too, but if you're locked into that solution, then I guess you could continue going forward with Samba CIFS, but I'd have more questions about what's going on at your site. Yeah, if you have support, I'd engage us through a support bug, and we can work with you to talk you through that of pros and cons there. Renetta, does the slurm.conf on the Slurmdbd need to match that on the Slurm controller node? So the Slurmdbd really only looks at the ports and then the name of the cluster. But ideally, you'd want those synced up just to create sanity throughout the cluster. Luke, why isn't enable RPCQ documented? Others here in the chat, it sounds great. Is the plan to document that in 2108? I don't have a date of when we plan to document that. We still consider it feature preview. We are working with a few different sites to see how that behaves and what type of issues they run into. For part of the sites, it's worked well. For some, they've had to disable it. But as stated before, let us know if you end up enabling it so we can work with you and solve those issues. But for right now, no plans to document it as of yet. Renetta, does Configless also update the slurm.conf on the Slurmdbd? That is a great question, Renetta. For the Slurmdbd, I am not sure. But we can get you an answer if you reach out to us through support. Rafeli, --batch script catch command submitted with --rep. So --rep should also store that output as well. For Vinod, no space left on device is only fixed on Slurm'2108. Yeah, the complete rewrite for Cgroups v1, which catches that and the other bugs you've ran into, is only fixed in 2108. All right. Thank you all, and I appreciate you tuning in. That's it for the questions for today. All right, the next presentation is by Nate Reaney, going over the REST API and also containers, starting at 10 a.m. Mountain Standard Time. It is on a separate YouTube live stream. Please see the SchedMD YouTube channel for the link or the agenda. Thank you.